folks we're going to be hearing from. So let's give them a round of applause, please.
Hello, everyone. Thanks for coming out. Last day of Devcon. I know a lot of you guys are travel internationally, so it's not easy to come out on a Friday afternoon. One thing I'll say before we start is if there's a lot of open seats in the front here, there's desks too if you want to pull out laptops. So people coming in just want to move up towards the front, fill it up. That'd be great. So this is actually mid-presentation, but what I wanted to do is start off with a bit of an intro to this session and why we're doing this. We have a really big cast of folks here from Xerox PARC, from Ethereum here today, and I think one thing I wanted to maybe set the stage for, and because I do want the actual developers of the different apps and frameworks to speak more on the details, but just sort of more why are we doing this? What is the significance of all these apps we deployed at this conference? So I'll start a bit with that. But first, actually, just a bit of an anatomy of this session. So we have an hour and a half for you folks here. And for those live streaming, also thanks for tuning in. We'll start with after my session, we'll start with 2 lightning talks, one from the FrogNet by Forrest, and the other on Meerkat, which is this Q&A app we're using that uses Zupass. Following these lightning talks, we'll get into the workshops. So these will be from the library developers, Veronica and Rob, who will introduce. One is going through and building a KYC system with pods and GPCs, a ZK KYC system, and the other is introducing this ZAPI, which is the framework that both FROGCRYPTO and Meerkat have used for building on top of Zupass. Cool. So I want to just spend some time on why we're doing this. And I come back to this interview or blog post by Vitalik, which is talking about sort of what he sees as a future of Ethereum. And one thing that stuck out is, how do we actually make Ethereum something that people use beyond just sort of like the interesting ideas that we had for the past decade? How do we actually scale this up? And I think that there's been a lot of really exciting direction in terms of DeFi, stablecoins, prediction markets, all those many things that other people have talked about. But this direction of making the internet more interoperable, more legible, this other direction of Ethereum has been kind of, in our opinion, underexplored. And adding on to sort of, Gubsheep's talks on contact with reality, I think a lot of this effort around Zupass and pods is very much in this direction of how can we get to making something useful in this other area or space of Ethereum's values. And one thing I want to talk about is how, we're all at a conference and how conferences can serve as essentially, early glimpses of reality for the future, right? So folks might be familiar with these 2 pictures. On the left is Doug Engelbert, who was formerly a pretty unknown Cornell professor who in 1968 introduced essentially personal computing to a wide stage. And again, it was all hard-coded. There's no actual product, right? But people saw for the first time the mouse, object-oriented programming, typing, video calling, all these different things. On the right, I have a screenshot of Twitter, which was available at South by Southwest at 2007. And it was the first time a lot of people were experiencing social media, which had come to define so much of this decade, for better and for worse. So one prompt I want to say is, given we're at an Ethereum conference, what did it feel like going to an Ethereum conference 5 to 10 years ago? And I'll preface this with, I actually wasn't part of the Ethereum ecosystem 5 to 10 years ago, so I'm sort of guessing here. But and I'll focus on it from a technology perspective. So you kind of have a few different core functions of a conference, right? So you have your ticketing system, who's allowed to come in. You have your communications. There's things like talks, events, whatever, right? And you got these people that come in. And there's data that lives here. There's, for example, your ticketing data. Are you allowed to come in? There's messages you send to people. And there's things you do at talks, for example. And that was 5 to 10 years ago. How has it changed in about 10 years? Well, the main thing that's changed is really just this bolded arrow here, which is now you can, pay for your tickets in Ethereum. And I think we can do a lot better, right? We can do a lot better than just payments. So just to explore, what could it look like in the future to go to an Ethereum conference, right? Well, all these different functions, can be smart contracts. We can have all our data stored locally, right? Everything is composable. essentially, an Ethereum conference, or eventually the world, should run on Ethereum, or actually have some plausible story for running in this manner. And my take is that if we can't actually get to something like this, then that's an indication of something being seriously wrong in terms of what we're all building here, right? So here's one exercise, which is, what would it take to run a conference like this entirely on mainnet and rollups? What are the benefits? I think people probably here already, pilled enough to go, but I'll just sort of go through. Composability, ownership, permissionlessness. Everything's verifiable, which means it's portable across different platforms, including all transformations on this data. But this is obviously not possible because of a bunch of obstacles. Everything's public except for cryptography, unless you use advanced cryptography, which others have explored in this session. A lot of the data is still out there on Google and other services. Development is really hard. I mean, just to the kind of extremely adversarial environment of smart contract development. And it's expensive, gas fees, et cetera, et cetera. So in 2024, going all in is still too high friction. And that doesn't mean that we can't start taking steps in this direction, right? We can't start, 80-20ing ways to start getting contact with reality and start deploying these sorts of, mechanisms. And one observation is applications like Zupass have really started to make this possible, but specifically because of two different things. One of these things is called pods, which are essentially interoperable data. This interoperable data format that lets you specify essentially arbitrary statements about the world and a proof of its existence, and an ecosystem of apps, which we're currently calling zaps. And the data is not stored on Ethereum. The compute doesn't happen on Ethereum all the time, but it's easily verifiable on different computing platforms. It's easily portable across different applications. And just to give a quick primer, kind of repeating what I said, here's these vocabulary terms that you don't have to take notes on because folks will be diving deeper into them in the next 2 hours. So here's some examples of pods you might be familiar with just from this week, right? Your tickets, other events that you've been to, frogs, collecting, essentially POAP-like event collectibles from going to certain talks. And also different kinds of zaps. We have everything from getting testnet ETH to things like mixing two frogs together to things like conference infrastructure like Zucat, which determines who's allowed to be in the Telegram group. And given all these new technologies, what can going to DevCon really feel like, right? Well, these applications essentially form a network where the data is stored locally within your Zupass as pods, but you can take them at will between different applications, and you can use proofs of them in order to get access to services, which is a really interesting, which is obviously not the full scope of what's interesting with, programmable cryptography, but it's at least a step in this direction. And one interesting thing that sort of organically happened with FrogNet is that it's sort of expanded into a tree of different apps that consume frog data too, right? There's things like Necklace, this website that stores necklace QRs. There's things that let you mix two frogs together. There's things that let you verify frogs on chain. So that's been really exciting to sort of see that happen because of the new capabilities from pods. And obviously predicting is really hard, but what's a projection of what this looks like and at a grander scale beyond conference data? Well, things like check-in, things like communications, things like voting, games, social, right? They have analogs in the real world beyond what's going on at DevCon. So I think you can pretty quickly sort of see the pattern match into how this is actually relevant and why it's actually worth caring about, even if you don't care much about just this, things that happen within this conference. That's the sort of primer on, introducing these topics and why this is interesting. I'll sort of move more into a kind of just fun phase of requests for projects. I know a lot of folks here are developers. And I just want to throw out some ideas ahead of these sessions. So the first thing is a frog social graph. So, I can see my friends in my screen, right? But I want to be able to see sort of more analytics or information about what's going on. I want to be able to see things more visually, right? And on the left here was a graph from actually the Meerkat team when they were at ETH Berlin. They created this sort of social graph of Zupass attendees, and I'm wondering if that should be an extension of the Frog Friend Finder on Frog Social. Another direction is you can have something like discovery be better, right? On the website where people have been posting their QRs. I've realized like this is really exciting and cool, but it's not really like a fun, easy interface to explore around. So there's this direction of like, hey, maybe I have 5 swipes an hour to go through and make friends with people, refreshes every hour or something like that. That would be a cool sort of front-end project to explore. One thing we're thinking about as well is moving beyond what we've been calling Pod 1, which is sort of the ZK-friendly version of this data, and extending into more real-world data that is more cryptographically difficult to verify or to prove and verify on lighter devices. So things like ZK email and TLS notary are things that would be exciting to get into the pod format. So that closes off a lot of my introduction. I want to sort of cede the floor to our presenters for today, specifically Forrest, who's coming up next to explain Frog Crypto. And on that light, I want to show this little surprise here into the froggy void. Thank you all. Cool.
All right. Awesome. Another round of applause for Richard, everybody. We will, if you didn't get a chance for that QR code, we'll try to get it back up at the end of this session. Amazing. As Richard mentioned, we're going to be having a series of lightning talks, actually just a couple lightning talks, and then we'll get into some longer form sessions. If you need anything to drink, there's a whole table of water at the back. They've got little cans of water, so help yourself. I'm also seeing some frog plushies being laid out. So if you haven't been able to get yourself a little frog plushie necklace and you want one, we've also got some at the back there as well. And how we doing? We're looking good. Amazing. So let's welcome to the stage Forrest. Forrest is going to tell us more about FrogNet and Frog Crypto and all the fun stuff. So round of applause for Forrest, please.
Hello. Hi. So my name is Forrest. I'm the main developer for the FROGCRYPTO. And if you were at Devcon last year, you probably have played FROGCRYPTO. And this year, it's kind of a similar game, but it's also kind of quite different underneath. So I will be talking a little bit about that during this session. So first of all, what's FROGCRYPTO? You probably already seen it. When you use the Zupass this year, there is a button that just says score, and when you click into it, you are brought into this experience. And if you have stopped by our Frog physical booth, you probably received this pamphlet, which explains there are kind of 3 main ways of getting frogs this year. So the first way is you click the button every 15 minutes, and then the second way is there are physical frogs around the venues, which you can scan with your phone, or rather tap with your phone. And then the third way is many of you have already had the frog necklaces, which has a QR code on it. And by scanning the QR code, we'll be able to connect with other froggy, or rather make other froggy friends. And then finally, once you have lots of frog points, you can go to our frog shop to get more swags. So kind of dive deeper a little bit. So last year, might be what you have seen, and then this is this year's. The main difference is actually, last year this was actually part of the core Zupass applications. And then this year, this is actually built as a ZAP. So what is a ZAP? A ZAP is a kind of a dedicated, yes. Oh, yeah. So the ZAP is really kind of like a DApp, if you will, where it is a kind of a standalone applications, but can be connected to the Zupass, which, if you remember, it's a kind of end-to-end encrypted kind of data storage, and more than that. But that's kind of one of the primary use cases for us. where you can kind of create these, store these pods in the Zupass and also read from it. So kind of one of the significant thing you can see is that you probably access the FROGCRYPTO through the Zupass interface, but you can similarly just the same access this as a standalone app, which it actually happens the other way around, where when you visit in this mode, it actually has a hidden Zupass as an iframe in this domain, versus when you visit in the Zupass, the FROGCRYPTO lives in an iframe within the Zupass. But in either case, that they both establish a connections so that your data can move around between your data storage in Zupass and the Zap of the FROGCRYPTO Zap itself. So there is this wonderful documentation that being put by the core developer of Pod and ZAPI, and dive more deeper into how you could build a similar Zap yourself, and even consume data from data that's produced by other Zaps, which is kind of the whole point of Pod and Zupass. So here just is a quick view of kind of some of the core data structure of the Frog. On the right, this is what you see in the app, and on the left, this is like individual entries to kind of represent where your Frog underneath. And then finally, we have the signature and the signer public key. Again, kind of one of the cool use cases is this is a ZK-friendly data structure, so you can use this kind of Frog to build any kind of app that you might want, whether that leverages zero knowledge or not, like Richard just mentioned in the earlier session. Jumping onto kind of the second way you can collect frogs, if you have seen these physical frogs around the venue, you can tap with your phone if your phone have NFC chips, and that will give you a frog. And so underneath it, what really happens is, if you remember, you have these buttons you can click to collect frogs. Every kind of these physical frogs acts like their own button. So really, what happens is there's these invisible buttons that you can click on. And then every these NFC chips creates a signature whenever you tap it, and also create a nonce. So this become a nullifier we use, so that every tap can be consumed only once, and then the backend would, the server, once verifies that will issue a pod to you. And then the thirdly is kind of, this is a great new feature that we made this year called Frog Social, where people can connect with each other. The way that works is actually you're assigning a frog yourself. So up to now, all your frog are assigned by a single private key that's stored in our server. And as you probably know, every Zupass has yourself have your own private key pair. So what Frog Social leverages is that allows you to assign your own special frogs and send to each other. And in fact, this has taken off quite widely for us. People have been super creative on how they can kind of create more connections, and then there are lots of enthusiastic people who kind of build app around it and even write blog posts around it. And in fact, we had 500,000 frog pods that has been issued over these only 4 days. Where 400,000 out of them are frog connections pods, where more than 100,000 frogs that are kind of the regular pods that you collect from the button and cyber frogs. Finally, I just want to quickly plug on the two of the amazing applications. One allows you to use the pods from FROGCRYPTO to create new pods. And then the other one that's built from our Builder Guild friends, which allows you to kind of take pods and put them on chain. Yeah, so kind of that's the end of my sessions.
All right. If you'll entertain us here for a second, Forrest, we have got some questions vis-a-vis our lovely Meerkat app. Backstory of frog lore. I'll let you pick. Do you want to answer the question, what is the backstory of the frog
Backstory
lore?
of frog lore. If you're asking about frog crypto itself, this is more just around like programmable cryptography, and people said we had the Prague Crypto conference last year, and that's where the frog crypto came from. But if you're asking individual lore of the frog themselves, we have an amazing person called John, and he's the mastermind behind a lot of creatives here.
Can you model simple CPU like Intel 4004?
That's a different session. Tell us the secrets of the void. Yes, the secrets of the void is a great segue to the next session. Actually.
Amazing. Okay. Is the other session that you said this CPU question might be answered, is there an actual session, or is that
I think that's Brian's question from
All right. Well, we'll get the answer to that during Brian, and scan those void QRs, and also stay tuned for the next session to get your answer to the void. I'm going to wipe all these questions clean and allow you to ask new questions for the next segment, and that's actually a great segue. Because up next we're going to have the Meerkat team. So if we can have a round of applause for Richard, we'll let him Forrest. We'll let him get his machine unplugged, and we'll swap in a new machine and get the Meerkat team up here. So thank you so much, Forrest. There's a little bit more lore behind the frog crypto. It's actually debated. I was hearing it debated at a dinner the other night as to whether it was a typo in a Telegram chat or you've got their machine set up? Okay. Whether it was a typo in a Telegram chat or a marketing stunt or something like that, but we'll talk about that a little bit more later. I thought I had to kill more time. These guys are too quick. These pros are too quick for me to ramble on. All right, Miriam and Florian from Meerkat, let's give them a warm round of applause. They've been working their butts off this conference.
Okay. Does this work? Yeah, okay. Hi, thank you for coming to our talk today. We created Meerkat. You might have seen it on Twitter as a meme. You might have seen it at a talk you actually attended. You might have engaged with Meerkat by letting us prove and verify your Devcon ticket and give you an identity. You might have collected cards, attendance pods, and generated them into your Zupass. You might have created speaker feedback pods and collected those, and also let speakers collect their side of the thing. Meerkat looks like a web app. It is, in a way. Meerkat itself and its main functionality is a speaker audience engagement tool for live audiences, and our vision really is to take in real-life events and the connections and interactions and engagement that people have there and speakers have with their audience and bring it into a virtual world and make virtual worlds more real. And because we are humans and we care about our privacy, we wanted to make sure that anything we build within this worlds we make with privacy in mind and use the cryptographic tools available to us. And so Meerkat is also using the toolkit, the Programmable Cryptography toolkit from ZeroXPark, and it's a ZAP that uses the Z API that generates and consumes pods, provable object data sets as pods, but also as pod PCDs, which is then the proof carrying data that GPCs can run on. And on top of all of this, or wrapped, we take the pods and wrap them in Zupass, so it's integrated with Zupass. To give you an overview of the Meerkat app and the pods we generate and consume, when users or attendees go to an event, they scan a QR code, they right away see the functions we have, so to join the Q&A, to collect a card, to generate and collect a speaker feedback card. And they can see the questions, but to interact with them, they need to prove their Devcon ticket. So the first pod PCD that we use and do is for identity. The second one that we generate is an attendance pod when you click collect card, and it looks like this in your Zupass, and then on the back side of it, you can see all the attributes. For example, because Meerkat is a fully open source app, when you go on our Twitter profile, you can get access to the GitHub repo and create extensions on top of it. It has an open API, and you can also use the pods that people created. For example, you could be wanting to reward your users for attending 10 sessions of the cypherpunk track, just as one idea. And then this is the first pod, which is an ownership pod, and then the second pod that we let people generate is the speaker feedback pod, which is a peer-to-peer pod where both the speaker and the attendee gets it into their Zupass. As we see, a Meerkat talk space as kind of a world where everybody has a role, so the speaker, the attendee, but also the moderator. So the moderator has an interface there as well where they can play around. And there could be more pods that we could generate, for example, contribution pods for all the questions asked, or also for the hearts that people click for liking or reacting to a talk, or the upvotes. And we might do this down the road, or you're all invited to build on top of Meerkat as an extension or on top of the pods. And there's also some limitations within Zupass, for example, for certain data limits. And I'll let Florian dive more deeper into the technical details.
Yeah, hello everyone, also from me. I'm going to try to speedrun technology now. So we have 3 levels of integration that you can do and you can use for your applications, and I want to go through them. So the first one is using Zupass as an identity provider. That's basically what we did for you to ask questions, for voting, and also for reaction. This roughly is like what the flow looks like. So basically, we create a ticket proof inside of the web app. This proof will be sent to our backend. It will be verified, and then you get credentials that you can use to create questions, react, or vote. However, a quick reality check. This is how it was implemented until Tuesday night, and then we realized that it can be hard. So there's a few challenges that we faced once we rolled this out to 12,000 people. One was like, there's an extra pop-up screen that asks people to prove stuff, which from the UX side, everybody's like, what is ticket proving even? What is GPC? So one thing that was hard, and we also like had to remove at some point. The other thing is that GPC proving on ticket proving on mobile took sometimes up to 10 seconds, something that is like from a user experience point, and we're talking about consumer applications here, can be a very long time. And lastly, there was some setups, and specifically older devices, where this even failed in the end. So this is the reason why we actually changed up the flow and then allowed people to provide us the pods instead of creating the ticket proofs right on the device. However, going on, I want to go to the second level of integration that you can do with your app, which is the ownership part. So collecting the attendance POD. This is roughly what it looks like on our end. So when you scan the session QR code, you will be able to request an attendance pod from our backend. This session QR code that you see next to the screen usually has a secret in it, so going through the PWAs and clicking every single link will not help you. But once you do that, the backend will allow to create a pod that is signed by our server and then be sent to your Zupass. I wanted to quickly also show you what this pod looks like and hint a few things here. So one thing that is recommended to have is the pod type. We use the reverse domain and then / the type, as well as the version number for people that are consuming it. And there's a few special fields you can make to make it look pretty. And last but not least, the owner is really important here because otherwise we could have people basically sharing pods with other folks. But we really want to make sure that the owner is bound to like one of the Zupasses. Moving on, last integration step that I want to talk about, and something that we also heard about in the FROGCRYPTO already, is the peer-to-peer approach. So basically, this is what we do with the feedback pods. So attendees can sign a pod, which is sent to our server, acting as a relay, basically. So we will forward the pod later to the speaker, and then the speaker can pass it or like save it in their Zupass. Again, here's a quick summary of what we're doing. So there's a pod type and then also a version. This one doesn't contain an owner because we didn't get to the ability to share actually the owner key of the speaker. But ideally, you would always have like an owner inside of a POD. So quick takeaways for you and learnings that you can use for your apps. One is like integration is key. So for us, a major push was that Zupass was the ticketing, Zupass was the identity. So coming to this conference with this integration was key. The other thing is like client-side proving, as I mentioned, can be sometimes difficult, and that's why we needed to make adjustments. And the last thing I wanted to talk about is keep your downstream consumption in mind. So who else will be using the pods that you create? Because probably you've already thought about it a little bit, but our pods that we have could also be used in other use cases. around this event. Thanks so much.
Awesome. Thanks so much, Meerkat. We're a little tight on time, so I think we have time for one question. The top question.
How many SPOFs does Zupass, Meerkat, FROGCRYPTO have? The server verifying proof, can it be decentralized somehow or run locally? Is this one of us?
I'm not entirely sure. Maybe we can talk about it offline. But I think like the decentralization.
This one might be good.
The decentralization part might be where it comes tricky because we still want to authenticate basically a certain attendance pod that you can then use and say like, hey, this was actually created by us. Or in case of the feedback pod, something that's always that's been created by a certain Zupass identity. But I'm happy to hear any ideas how we can bring it there basically in the end.
All right. I think this DNS ENS question was actually for a previous talk, so let's just skip to the pod-related features, and then we're going to have to say thank you guys. And if you guys have more questions for the Meerkat team, this is what they look like. They'll be hanging around after the workshop. You can come chat to them.
I should answer that.
Yeah.
For future conferences, we have ideas such as letting people answer questions after the event is over and while the talk space is still open. Like, for example, if you click into the Passport app now onto a Meerkat link, you can still see the questions, so they didn't automatically shut, but speakers could be enabled to answer there or get more in touch with the audience members. There's also a DIP that we wrote in order to a Devcon improvement proposal that lists out some of the extensions idea we had if somebody is interested in that. Or yeah. Thank you.
Awesome. Thanks so much. So for new, can I have the QR code back for a second, just for 30 seconds here? So just for newcomers, once again, that was the Meerkat team. We are using Meerkat for Q&A for this whole session. You can scan this code. It'll take you to the session link in the Devcon app. If you scroll to the bottom of that session link, you'll see there's a Q&A section. You can click on that Q&A section, you can ask questions, and then upvote on your guys' questions. Now, because we're using the same Q&A session for all of these talks, I'm actually, after each talk, going to go through and wipe the questions away, because we don't want questions from a previous talk being answered by someone who wasn't talking about that stuff. So basically, I'm going to go check all of these questions out, and as our next presenter talks, Veronica, you can put in questions for her, and we'll have a Q&A session at the end. So without further ado, I'm going to bring up Veronica Zheng, and she's going to talk about Zoo KYC. So let's have a really warm round of applause for Veronica. Thank you so much.
Hello, I'm Veronica. So I'm pretty sure like you guys have been hearing about ZK zero knowledge this entire week. As a builder, you might be curious what kind of applications you can build with ZK and how to build it. So today I'm going to show you how to build an end-to-end ZK identity application. We are going to use two libraries, POD, Provable Object Data, and also GPC, General Purpose Circuit. So how many of you have been to the talk, I guess yesterday, on POD and GPC? I think the title is like Introduction to Provable Object Data and ZK Proofs of General, ZK Proofs of PODs. Raise your hand if you've been to the session. Okay, so for those of you who haven't been there, check it out when they post the videos online. So those sessions are very informative. Okay, so POD and GPC are built by 0xPark. So in the past few years, 0xPark has been experimenting and building many different ZK applications for end-user use cases. And during this entire process, we've been asking ourselves, how can we make this process super, super easy for other developers to build ZK apps? And POD and GPC is our answer. So here is a link to the developer documentation. Go check it out. Okay, so in this workshop, I'm going to show you this app called Zoo KYC. This is a demo app I built using Pod and GPC. I'm going to first show you, to demo this app, show you how this app works, and then I'm going to show you how to code this app step by step. So here is a link to the GitHub repo. So all the code I'm going to show you today is going to be here. So I really hope after seeing this example, you guys would be inspired to build your own ZK apps. I'm always amazed by how creative people can be. So here is also a link to our Telegram group. If you have any questions, we will be there to answer your questions. Okay, cool. So let's start with the demo. So before the demo, let me tell you a story. So one day I have this frog, Todd. He would like to buy a house for his family, but he couldn't afford it, so he is looking around for a mortgage. And then, can you guys see this? Let's see. Okay, so then he saw Zoolander. So Zoolander says, to qualify for a loan, you need to have a valid government-issued ID. You are not in the sanctions list. You are at least 18 years old, have at least 1 year of consistent employment, and have an annual salary of at least this amount. As some of you who applied for a mortgage before, you know you have to give lender lots of your information, your ID, your pay stubs. Your lender would get your information from, for example, Equifax to get your credit information. But in this case, Todd doesn't want to do any of those because Todd has never heard of Zoolander before. What if this thing is a fraud? So Zoolander says, Todd, don't walk away. Let's use this application called Zoo KYC. This is a third-party application. So how does this work? You can take this piece of data, we call it proof request, and then we give this proof request to Zoo KYC. So Zoo KYC can generate a zero-knowledge proof according to this proof request. And once Todd gets a zero-knowledge proof, he can come back and then put his proof here to verify that he satisfies those requirements. And once he verifies those requirements, he would get a mortgage. Let's take a very quick look about what this proof request is. Okay, so you can see this proof request, it says you have to have pods. So this is using the library provable object data we talked about. And then you need to have 2 pods. One is a government ID pod, and the other is pay stub pod. So for government ID, you can see you need to have ID number is not revealed, so we are hiding it. And this is not a member of the sanctions list. So we have sanctions list here. And similarly, there's date of birth. You have to prove it's in the range. So it's to prove you are at least 18 years old. And then we are skipping to pay stub. So pay stub also need to prove this social security number not revealed. This entry equals to the social security number in the government ID. I'm not going to go too much in detail here. I'm going to show you in detail later when I show you the code. So here, Todd takes the proof request, goes to Zoo KYC, and then put his proof request here. Now you have the proof request. So to generate this proof, so here we are using the library general purpose circuits, GPC. So we are going to make proofs about 2 pods. One pod is ID pod. The other pod is a pay stub pod. How do we get the ID pod? So we are going to get ID pod from this ZooGov. ZooGov is a government for the zoo. So it's they issue ID to the zoo animals, and that's where we are going to get the ID pod. So we are going to this zoo government website, ZooGov, and then Todd is putting in his information, credentials, and then log in. So he would he would need to like upload his ID card here. I'm not going to upload it now, but then he needs to provide his public key. So here for the identity information, we are using semaphore library. Okay, so we are going to get the public key from here. And then this is Todd's public key. And then we are generating an ID pod. So here is the ID pod. You can see like there's entries. The entries has date of birth, first name, ID number, last name, and social security number. Those are the information we normally see from the ID. And then here we have the owner's public key. This is the public key we just pasted here. So this is like, okay, we issue this pod specifically to Todd. And then we can also see there's like a signature and signer public key. So this piece of information is actually signed. So this signer public key is this ZooGov's public key. You know, so like other people cannot tamper with this information, and it also proves this ID pod is issued by ZooGov. And so let's copy paste, let's take this ID pod and then put it here, the ID pod. And next, we need paystub pod. Similarly, we are going to get this paystub pod from this organization called ZooDeal. What is ZooDeal? ZooDeal handles all the HR information in the zoo. So we are going to go to ZooDeal. Still, we are going to put in our credentials, log in, and then we need to provide the public key for pod. For Todd, and then let's issue a new paystub pod. So for paystub pod, we can see we have like annual salary, current employer, first name, issue date, last name, social security number, start date, and similarly, we have this owner, which is Todd's public key. This piece of information is also signed. The signer public key is ZooDeal's public key. Okay, so Todd take this paystub pod and then put it here. So now we have the pods. We also have like the proof request. So we are ready to generate a proof. So here we are using like the GPC library to generate the proof. We can see like the proof is here. So it has like 3 pieces of information. The first piece is this proof. So for those of you who has been used like Circum before, you know this is like the result from the Circum, like using Ground 16. And then we have this like next piece of information is called bound config. So this is the same thing. This matches the thing proof request. So basically, this piece of information is exactly the same as proof request. And then we have another, the last piece of information, which is revealed claims. So here, what we are revealing like inside the government ID pod, we are revealing the signer public key. All the other information are hidden here. We are now showing like the date of birth. We are now showing the social security number. And for paystub pod, we are revealing the signer public key here. So we are also now revealing, you know, like a Todd salary or something like that. And then here we have like owner, membership list, and watermark. I'll explain later. Okay, so now we have this, Todd has this proof. So he takes this proof and back to the Zoolander. So he gave back the proof to the Zoolander, and then Zoolander can verify the proof. Okay, congratulations, now Todd has this proof verified, he can get a mortgage. Cool, thanks. So let's go to the code. So this is a GitHub repo I just showed you. It has all the code. The application I just demoed is actually deployed. So if you go here, you can go to see this deployed application, and you can try it out yourself. Then, it explains the code and the code structure. And here, you can actually run this code locally. So those are the commands you can use to actually run it and try it out. Okay, so next, let me actually show you the code so you can see the code here. Okay, let's see. Can you see this? Okay. Yeah, so let me know if it's too small, you can see. Okay, so in this like apps folder, there are 4 things here. So when I built this app, I first built this like pod issuer client and pod issuer server. What does it do? It actually like issue the pods. So for example, like this code, like for the ZooGov and ZooDeal, those things live in this like pod issuer client and pod issuer server. So there has to be a server here because like first, for normally the government website, the server needs to talk to the database to verify, okay, you are actually Todd, and then let me generate a ID pod with your information. So that's first. And the second is like, because the pod needs to be signed, so you have to have like the private key, the Zoo government's private key. You can put it on the client, otherwise you would leak the key. So we need to have a server here. Okay, so let me show you the piece of code which actually would generate the pod. So this is the code to generate the pod. You can see it here. This is using the pod library. So it does like pod.sci. If you look at this thing side by side, right? Let's see. You can see like this side by side, you can see this actually matches all the information here. So for example, there's ID number, there's like type and value, there's first name, last name. So this part should match like this thing you want to generate here. And then like you have to provide the government's private key to sign this piece of data. I hope this is self-explanatory, so it's like clear how to generate the pod. So that's the first thing I did. And then I started building this Zoolander. Because in order to generate a proof, we need a proof request. So what kind of proof you want people to generate, right? So this is the verifier provide a piece of information like a proof request. So this piece of code is inside this folder called GPC verifier. So let's look at the code for how to generate a proof request. Oh, okay, it's here. So to generate proof request, let's see the code here. So if I put this side by side, you would see like this piece of code would match exactly this piece of information. So basically, you need to have pods. So we are going to make proofs about 2 pods. One pod is like this government ID pod, and another pod is this pay stub pod. For government ID pod, what are we going to prove? Okay, we are going to prove there's this ID number, revealed is false, so it's hiding. This is not part of the sanctions list. So the sanctions list is here, right? We are sanctioning those IDs. And then there's this date of birth, also now revealed in this range. So it means you have to be at least 18 years old. And we also have social security number, also not revealed. We needed to provide the owner here. We are using the semaphore library for the owner. So, and then for pay stub, we needed to have social security number. So this pay stub social security number has to match the government ID social security number. So it's for the same person, Todd. And we have start date. So this we want to prove that like we want to say, okay, have at least 1 year of consistent employment. And we don't want this let's say if someone has pay stub like from last year and he's been unemployed for this entire year, right? So we want to know the issue date and have some like range requirement for the issue date. And this last thing we want to prove is annual salary at least 20K. Okay, so I hope I can convince you that like those requirements we specified here is the same as like this requirements specified like by Zoolander, so no more and no less. Okay, so there's also like two extra things. One is nullifier. So we need to generate nullifier to make sure like Todd doesn't use this proof to get many mortgages. We don't want him to use this this proof like more than once. So nullifier would hash this external nullifier, which is ZKYC, and also a secret derived from Todd's private key. So we can use this nullifier here. And then we also like have a watermark. This is going to be carried to the proof. Okay, so that's all about the proof request. So when we have the proof request, the next thing I'm going to do is to generate a proof. So ZooKYC is this app is a piece which generates a proof. It's a prover. So the code is in GPC prover client. Okay, so let me find the code to generate the proof. Okay, so this piece of code is inside the GPC prover client, and then this is using the GPC library. So the main call is here. It's like GPC proof. So it's going to take three things. One thing is this proof config. So this proof config is a proof request I just showed you, and then it's going to take proof inputs. So the inputs. We can see the inputs here. It needs to take the pods. So those are the two pods again, and it's going to take the owner and also like this external nullifier, membership list, and the watermark. Those three things are also from like the proof request. And then the last piece of things it's going to take this artifacts URL. So it needs to like either download or somehow get this artifacts. If you are familiar with Circum, you know like when you generate a proof, you need to like have binaries, which is like your Z key to generate this proof. So this is what it is. So if you call this, then you would have the proof. So this is what this piece of code does. Okay, so now you have a proof. Now we are going to go to the last part, which is verify the proof. So verify proof, this piece of code is inside verifier. So it's here. And then let me show you the code. Let me find the verify proof here. Okay, so this is a code for verify proof. It's inside the GPC verifier. So the main piece of code here is calling like GPC verify. So this is also using the GPC library. So it's going to take the proof, the config, and claims. So those three pieces of information is the thing I just showed you here. So those results, remember, has like the proof, has a config, and also has reviewed claims here. So it's going to take those three things and also the artifacts URL. So this artifacts URL has like the verification key here. And then you can verify the proof. But calling this like a GPC verify is not enough here, right? Because it basically checks, okay, your proof is correct, but you need to do more things. So one thing I need to do is like, I get this signer public key here. Like this is a government ID signer public key. I have to make sure this public key is actually the government's public key. It's not just from anyone, not from Todd himself. We also need to check similarly the paystub's public key is like the zoo deal's public key. Here we need to check, okay, the watermark is calculated correctly. And lastly, we are checking nullifier. So basically, I have a database which saves all the nullifier I've seen so far. And here, like when I get this piece of proof, I check, have I seen this nullifier before? If I've seen this, that means like, okay, this is from someone who already got a mortgage. I can't give him mortgage again, right? So, okay, so those are all the code. Those are all the code I have. I hope like after seeing this, you are going to take a look at our code base and you know, check it out, try it out, try to build something, and maybe also like join our Telegram group here. Cool, thank you. That's my talk.
All right, we have some questions for you, Veronica.
Does this system require the data issuer to set a pod, or would it be possible to dictate from some existing side data source like a passport and verify the signature as a part of a pod? So you can, it's possible to take data from some existing. Oh, I can't see it anymore.
Sorry.
Yeah, it's okay. So like you have to. One thing is anyone can issue a pod, right? You can also take a passport and then issue a pod about the passport, but you have to trust whoever issues the pod. So like if you trust, in my example, you trust the government, ZuGov. So like that's the only thing you are going to trust. But you can say, okay, I'm going to trust this other organization. Like for like if this organization like issue a passport pod, I'm going to trust that organization. That's a public key you are going to check. So it depends on like who you want to trust, I guess. Okay. Doesn't this imply that Zoolander needs to accept the claims of all these proof providers are valid? What tells them these providers are legit? So it's the same thing. It's like for this Zoolander, it's basically the Zoolander says, okay, I'm going to trust the ID issued by this ZooGov. I'm going to trust like the pay stub issued by this ZooDeal. So that's trust assumptions here. You have to trust someone, right? Like the ID is issued by the government, basically. Does the burden of proof for truthfulness fall on the verifier? What happens if the verifier pod issuing authority? Yeah, that's yeah. If like ZooGov just like issue something like totally doesn't make any sense, like a fake ID, then you know, then this whole proof would fall apart. Okay, so do I still have more time?
You have time for one more.
Okay. Will the proofs work if the request data is only a subset of the data? If all you wanted was to prove that someone, oh yeah, definitely. So let's say like I only want to prove like this Todd is older than 18. I can still use the same ID pod I just showed you. Like for my proof request, all I need to say is like, okay, this date of birth is in the range. So like, just check this thing. You still need to check like owner, like the public key, but like for this piece of information, you can only check date of birth. You don't need to check like other things. You can just ignore the other things you don't want to check. Yeah, that's.
Amazing. You're right on time. Excellent job. Let's give Veronica a warm round of applause. Excellent demo. Finished on time. Finished Q&A on time. I think that might be 1 in 10. Thank you, Veronica. While we get the next machine set up, we're going to keep this QR code. Reminder, we only have one Meerkat instance for this presentation, so the same one we just used for Veronica's Q&A, we're also going to use for Rob's Q&A. Rob is up next. So PSA, I'm going to go and delete all of these questions so that there's a fresh set of questions that you can be asking Rob as he's presenting. But the way you get to ask those questions and upvote is you scan this QR code and you go to the bottom of the event link that it takes you to where it says Q&A. you sign in with your Zupass, and you can ask questions and you can upvote on questions. So if you get sparked during this presentation, I should say, drop your questions in there and we'll leave time for Q&A at the end. And without further ado, I'm going to bring up my friend, Rob Knight, and he's going to talk about Z API. So let's give a round of applause for Rob.
Thank you very much, Remy. And thank you to all of you for turning out. I'm going to talk about the Z API. So this is the system that you use basically to integrate some of the Zupass features into your own apps. So just a quick recap on what is Zupass. Zupass is a private data store, which has a UI for visualizing that data. It has a suite of cryptographic tools, so you can sign, verify, make proofs about that data. It has UI to allow the user to do all of those things in a clear and easy to understand way. And the crucial part that I'm going to be focusing on is that there are APIs for requesting, updating, and sharing that data, which you can use to build your own applications. So here we have a bunch of different Zupass use cases, and the one in the top left, I think you will all have done, which is that you've checked into Devcon. If you didn't check into Devcon, you shouldn't be here. So that is something that you do using Zupass directly. You get your Zupass QR code and you show it and someone scans it. But all of those other use cases that we see here, those are implemented in other apps that use Zupass. So we have the voting for the hackathon winners at ETH Berlin. That was done using Zoopoll, which uses Zupass to prove that the voters are legitimate attendees of the event. But it's not done inside Zupass, it's done in an external application. FROGCRYPTO, if you heard Forrest's talk earlier, you'll understand how that uses Zupass. There's the ZooRat, which was used at DevConnect last year. You basically make a ZK proof that you're an attendee of the event. You send that to a Telegram bot, and it posts an anonymous message for you in a Telegram chat. Distributed trials. At ZooConnect last year, they built a system for participating in clinical trials. So they had wearable devices on your wrist that you would wear for 2 weeks, and then at the end of that, it would collect all of this data, and you'd submit that data with a zero-knowledge proof that you are a participant in the trial, meaning that they know that that data is coming from someone who did really register, but they don't know which participant submitted which data. So you get to preserve your privacy there. Zoom was used at Edge Esmeralda to enable people to share their Strava running routes, so you could see how fast people were running, but you didn't know who was running. In Gitcoin, there was also the Zuzulu Q2 grant round, where people, in order to vote for projects in the quadratic funding round, they could vote for events and tech projects to receive funding. That requires you to prove that you've been to a previous Zoo event. So again, zero-knowledge proofs being used to preserve privacy. And then the final example, bottom right, is Meerkat. Again, you will have heard a presentation about how that works for them and what their experiences were. So how does Zupass actually work? It kind of works a little bit like this. This is a very simplified architecture diagram. But we have Zupass, and inside Zupass there is a cryptographic identity, a semaphore key pair. There's a collection of pods, PODs, provable object data. So this is the things like your frogs, things that you might have received for attending a talk in Meerkat. Your tickets are also pods. And all of that data, that identity in the pods, that gets backed up and synchronized across your devices using this end-to-end encrypted backup service. So that's how you can go from your phone to your laptop and you still see all of your data there. That data never leaves your device in unencrypted form. It's always encrypted. It's never shared with anybody else. Zupass also has this system called GPC. Again, we've just heard from Veronica, a really good example of how GPC is used to make these kind of customized ZK proofs. And then we have these APIs that tie all of these things together and allow external apps to leverage this functionality for themselves. So in Zupass kind of API 1.0, basically how we were building things earlier this year and last year, it kind of worked a bit like this. You'd have an app. So here we have, again, an app that was built at DevConnect last year. And that wants to know, is this person a DevConnect ticket holder? Was this person actually here? Because we're going to give them some testnet ETH if they can prove that they were an attendee. So what you do is you click the button, and then this green pop-up window opens up. So it opens up a pop-up window on zupass.org. That then synchronizes your data down. It then decrypts the data using your password. And it allows you to make a proof about that data. If you click the proof button, then the spinner spins for a few seconds while it makes the proof, and then it sends the proof back to the original app. And that allows people to kind of build these kind of simple authentication workflows, which works it works pretty well for things like requesting a single ZK proof, but it doesn't work so well for more complex interactions. So FROGCRYPTO 1.0 last year, again, you might have seen this at DevConnect. FROGCRYPTO needs to do something more complicated. It needs to be able to write data to your Zupass, and it needs to be able to write multiple pieces of data to your Zupass. So, you're tapping that like search the swamp button. You get a frog, and you get another frog, you get another frog. You need to be able to insert those into Zupass very, very quickly. And if you have to open up a new pop-up window every time you want to do that, it's not going to work. That's a really bad user experience. So we solved that last year by just building FROGCRYPTO directly into Zupass. And then FROGCRYPTO has access to these private APIs where it can directly insert things into your storage. But that's not really a scalable solution. We couldn't then come back this year and say, okay, the Devcon PWA is going to have to be built into Zupass. Meerkat is going to have to be built into Zupass. All of these applications have to be committed to our code base. So we wanted to come up with a solution that would allow apps to leverage some of this functionality that's in Zupass in a way that allows them to be independent apps that consume Zupass using an API that feels like, under the hood it isn't, but it feels like using an API that's talking to a remote server or is talking to a browser feature. And this is something that we call the Z API. And this is a new thing that is being used basically for the first time at DevCon. And this allows you to build your own app. You basically get to integrate all of the features of Zupass. So you get access to that pod store, the store of all of the data. You can read and write to that. You can run queries over it. You get to use or at least request the use of the user's identity. So you can request that the user sign something or that they make a proof that uses their identity. And you get these UI primitives that, for instance, visualize a proof. So the user is being asked to prove something. What are they being asked to prove? That UI is pre-built for you. And you can see some examples of things that people have built. One of my favorites is the Shulgin.engineering, which takes your frogs and develops psychedelic substances from them. It's pretty cool. So this is a slightly different architecture to the kind of the V1. In this, the app is like a regular web app, and it can do regular web app stuff. It can talk to remote servers. It can do all of those usual things. It has JavaScript. But it also has this embedded Zupass. And the embedded Zupass can do all of the things that Zupass can do. So that can query things from your pod store. It can access your identity. It can invoke these cryptographic gadgets to generate proofs and so forth. So now your app has basically all of the capabilities that Zupass does. And it can use and reuse data that other apps have created. So I can create an app that, with the user's permission, will read from their frogs, for instance. So I can create an app that consumes that frog data and makes new novel proofs about it. I can combine frogs and tickets and make novel proofs about those. And I can insert things into that same collection. So these games or these interactions and experiences become open worlds that you can extend and combine and create new variations on. So how does this actually work? You connect to Zupass using a hidden iframe. So Zupass basically loads up in this iframe behind the scenes. And communication between your app and Zupass is done by sending messages. So the browser has a built-in post message API, and this allows for real-time message exchange between the two applications. So this is actually much faster in many cases than doing a network request. The request is kind of basically occurring on your device. So you ask Zupass to do something, and all of the computation necessary to serve that request is happening on the device. It's happening on the phone, on the laptop. It's not going over the network and asking a server to do something, because in the case of Zupass, the server doesn't know anything. All of the data is on the client. So you can do things like read and query, you can insert, you can delete, you can request signatures, you can generate proofs. Now this sounds a little bit dangerous, so there is a permission system that allows the user to decide, which things is your app going to be allowed to do. Pods are divided into collections, so frogs are in a different collection to Devcon tickets, for instance, and an app might have permission to access frogs, but not Devcon tickets, or vice versa. You can also create new collections for your own app, or you can request access to a collection that was created by another app. You can also request the permission to sign pods. So this is basically the whole of the API. If you see this, this is basically everything you can do. So we have pod operations, query, insert, delete, subscribe, and unsubscribe. Basically gives you live updates to the pod store as it changes. And sign kind of asks the user to sign something. Sign prefixed is a kind of special type of signature for kind of unsafe signing. You can get the user's identity, you can get their public key, and you can request a GPC proof. So querying kind of looks a little bit like this. Let's say we have the frogs collection. We can request a frog with a jump score that is between 5 and 100, minimum 5, maximum 100. Or we can request a frog with a certain mood that must be a member of a collection. And that means it must have a value of either angry or lazy. If the frog is neither angry nor lazy, then it's the wrong mood and you won't get that one back. So you can use conditions like is member of, is not member of, and in range to construct your queries. You could use this on tickets, for instance, to select tickets from a particular event. If you have frogs, you can use the ranges in particular to get frogs with particular attributes that have particular scores. You can also create your own pods. So we've seen examples of pods earlier. You can create your own pods with arbitrary data, any type of data that you want that is supported by the pod data types. So here I'm just creating a pod with 3 entries, greeting, magic number, and email address. And then I'm asking the user, would they like to sign this pod? If they do, it will be signed with their key. And then I'm going to insert that into a collection called new pods. I can also then make a proof request, which looks something like this. So again, taking that same type of pod that I just created, I'm going to give a set of valid greetings. So we had a greetings entry. We're going to then specify, these are some valid greetings. There was a magic number, so I'm going to specify a range of acceptable numbers. And I'm also going to say there must be an email address. It must be a string, but otherwise I'm not going to constrain what I need that to be. And I want to know what the email address is. So what I'm asking for here is a proof that discloses an email address of a pod that has entries that are in the ranges or satisfying the criteria that I've specified. When I invoke that function, so when I call the proof function, that will then cause a pop-up modal to appear in the app where the user will be asked to agree to make that proof. So this looks something a bit like this. You can see that the proof request is asking for the email address, and in this case it shows, test@example.com is your email address, so that's what's going to get revealed in that proof. Importantly, this is transmitted via messages between frames, as I said before, so this data doesn't leave the device, it never goes over the network. It is very much a local operation. So this enables a bunch of different options for you. You can build apps that use Zupass as a primary data store, for example. So FROGCRYPTO uses Zupass as a data store. FROGCRYPTO doesn't store your frogs on a server. It stores your frogs in Zupass. And that is the only place that those frogs can be found. You can use it to then query data. So again, take FROGCRYPTO as an example. When it lists out the frogs, it's running a query against that data store. We've seen a whole bunch of apps that are using zero-knowledge proofs around, whether it's around tickets, whether it's around frogs, questions and answers. That can also be requested and visualized using the built-in UI. And then you can also request user signatures of pods. So in Frog Social and in some of the more kind of peer-to-peer communication scenarios, I can sign my own pods and send those to somebody else. They can then receive those and verify that they have my signature, verify that my public key was used. One way to think about this is that what we're trying to build here is something that sort of previews something that we expect the whole world will have, some years down the line. So if you think about what browsers could do 30 years ago, they could basically render text. And then someone figured out, hey, maybe we could do images, and then tables, and then maybe we could do style sheets, I think probably was one of the things that came next. And then after that, JavaScript, background requests, and it kind of rolls forward. Now we have cryptography in the browser. We have real-time communication in the browser. We have local storage. We have access to the file system. We have a whole bunch of things that weren't there in the original browser. And that process is going to continue. Our thesis is that programmable cryptography is going to go everywhere. And so it seems quite reasonable to me that in the future, programmable cryptography itself will be built into the browser. You'll be able to make ZK proofs using built-in browser APIs. But right now that doesn't exist. So you can use ZAPI to get that window onto the future that we think everybody is going to have pretty soon. So how do you get started with something like this? It's actually pretty simple. I'm going to walk through a small example. And this involves installing basically 2 NPM packages. So we install the app connector package, and we're going to install the ticket spec package. And this is how you connect. So you import the connect function. You define your ZAP. You give it a name, Devcon ticket verify. It's not a very imaginative name, but it'll do. You specify the permissions that you want. So in this case, we're going to request proofs. That's the permission that we want. And we want to be able to do that for the Devcon SEA collection. So then we create this object, Z-object, by calling the connect function. We pass in the details of our app, and we give it an HTML element on our page that it can insert the iframe into. So this is, I don't know, what, 10, 12 lines of code. We then define a proof that we want to make. So we want to make a proof about Devcon tickets. So we're going to specify that there must be a public key. So this here is the Devcon public key that was used to sign all Devcon tickets. We have the unique event ID that specifies Devcon. And we want to reveal the email and name of the attendee. So when we run this proof request, we're going to get back a proof with a name and an email, but also a guarantee that that name and email is attached to a legitimate Devcon ticket. So then we call this function, we call prove, we pass in the proof request that we just saw, and we want to restrict that to the Devcon SEA collection, so we're saying only use inputs from that collection. And if that's successful, we can then print out the email and the value, and what we've got back is this proof. So we're not just getting some data back without being sure where it came from. We're getting a full ZK proof. We can send that ZK proof to a server. That can send it to another server. Whole long chains of distribution can occur. And every step along that chain, we'll still be able to verify that that's a legit proof. We'll still be able to verify that there really was a Devcon ticket behind all of this. So I'm going to recap kind of briefly over some of the things that you've heard already and over the ZAPI in general. We have pods, and pods let you define your own data structures. You can define any data structure you like. You can give things their own names. You can create numbers. You can create dates. You can create strings. You can create EDDSA public keys. You can specify constraints on those things. You can specify ranges on those numbers. You can specify lists of valid public keys and so forth. And that allows you to say, this is what makes something a frog. This is what makes something a ticket. This is what makes something a record of attendance. And you can share both the structure with other people, so other people can then take that structure and say, okay, I'm going to make an app that reads that structure, that knows about what a frog is, that knows how to work with tickets, or knows how to make frogs and knows how to make tickets. GPCs let you create your own logic. So this lets you create your own ways of interpreting those things, ways of deriving meaning from one or more pods, collections of pods, where for me, what I care about is, I just really want to know, did this person attend this event? Somebody else might care about, what specific type of ticket do they have? Maybe we want to create something that's just for speakers. Maybe we want to create something that's just for a particular subcategory. So you can create your own custom logic using GPC proofs, and build your own ZK proofs just using this very simple configuration language. And then with ZAPI, you can build apps that leverage these things. You don't need to worry about building your own pod store. You don't need to worry about managing cryptographic artifacts, which is actually a slightly difficult thing. There's a lot of pain and difficulty that we've kind of figured out how to work around. We're doing those things that is now packaged up for you by ZAPI. And users will come bringing their pre-existing personal data store that they already have, with their frogs, with their tickets, and they can use that to interact with your app. And then, where might this go next? So, this interface is defined. There is a library that defines this. There's a GitHub repo called ParkNet Client, which defines this API. There's a kind of RPC library. What's interesting there is that you could take that and build your own client. You could take that and build your own thing that does the same job as Zupass. So there was a question earlier about decentralizing Zupass, and is it possible to replace some of these components with others? Well, if you have something that implements this API, it will do the same job as Zupass. So if you have a better idea for how to store pods, you have a better idea for how to synchronize them between devices, you can build your own client and it will be able to serve that same role. Instead of signing in with Zupass, you can sign in with something you built yourself that will be able to respond to queries and produce GPC proofs. So that's basically everything I have to say about ZAPI. I'm hoping you have some questions. I'm hoping I didn't go too fast through all of that. I know that was a lot of stuff to cover. But yeah, I'd be really keen to hear what it is you have to ask. And also I want to highlight, we have a Telegram chat. So if you're interested in building on Zupass, if you're interested in learning more about Pod, GPC, ZAPI, any of these things, please join our Telegram group. We'd love to hear from you. And yeah, that's me. Thank you.
Amazing. Thank you, Rob. I've literally been flying around the world with Rob for the last maybe year and a half while he's and the Zupass team have been implementing at pop-up cities in Zuberlin and ETH Berlin and ETH Prague and now Devcon and DevConnect before that. So it's been a wild ride. The amount of work you guys have done both behind the screen but literally on the ground has been really cool. You don't have to hope for questions.
Oh, wow.
They're here. So I'll let you answer them based on the upvoting. Okay. And before Rob does that, I'll just remind you, if you go to that link and you scroll to the bottom and you click on Q&A, you will be able to ask and vote on the questions you want to see Rob answer. So would you want me to narrate them for you, Rob, or would you rather read them? What's easy for you?
I'll pick these up. So that top question is a really good question. Where does the Zupass data store live? So it kind of lives in two places. The primary place it lives is on your device. So when you create an account in Zupass, you have no data. It's a new account. The first thing we do is we create a cryptographic key pair for you. And you add a password to your account. We then take that cryptographic key pair, use your password to encrypt it, and then we synchronize that to basically a cloud backup. So that's just that is just a backup of that data. It's not the primary store of that data. It's just a backup for that data. But that allows you to sign in on another device, download that backup, and enter your password, and you'll be able to decrypt it. So the data, in terms of being usable, is only ever really usable on your own devices. That backup server is operated by us, so I suppose in that sense it is a single point of failure, and that's something that, for decentralization reasons, it'd be good to have more options for where that data might live. We do also have an export function, so you can just export your data directly and import it directly. So I think thinking of the data as living somewhere, I think it lives on your device, and there's a sort of cold storage backup that is totally encrypted. I think the second question is basically answered by the first question. So the server can't see your data. The server only sees an encrypted blob. Your password is necessary to decrypt that blob. The server can't see what's going on.
Did you answer this Is that what you're referring to? Can you send pods? What if I want to move, remove, and send a pod?
So, I mean, you can send pods. You can send pods by just copying and pasting. So I think we have like I think we have now a copy pod button that just gets a sort of JSON export of the pod. You can copy that. You can put it in an email. You can send it over Signal or Telegram. There is no kind of like built-in like send somebody a pod in Zupass functionality right now. That's something that we're kind of very interested in adding in the future. But pods are provable object data, but they're also portable object data in the sense that because they have signatures, you don't need to care about like how you got the pod. You need to care about whether or not you can verify it. So does it have the right public key? So in that sense, the transport it's kind of transport agnostic. So I think this question is sort of relating more to Zoo KYC, but I think it's a relevant question for just any situation like this. There is definitely a challenge of like getting people to agree on structure. So like what is a ticket, or what makes something a valid ticket for a given purpose? That's a question that comes up a lot. I have this Devcon ticket. I make a proof about it. How do you know that that's actually a valid Devcon ticket? Well, you do need to know some information. You do need to know some things. Like you need to know what's the Devcon public key. If you don't know what the Devcon public key is, then I could be presenting you with a proof and you just can't interpret it. So there is some information that is needed. That would obviously be published by, for instance, the Devcon organizers might publish that key. We, in the past, have published lists of interesting keys for kind of certain authorities like Zuzulu, DevConnect, and so forth. You also need to know things like unique event IDs. Again, we've also published lists of those in the past. This is something that in the future I would imagine registries kind of springing up to serve this use case. Embedding on the data client side, yes. I mean, like, yes, in the sense that if you end up with like gigabytes of data and you have to be synchronizing that back and forth all the time, I think that would end up being pretty slow. One of the reasons for making, for sort of breaking pods up into separate collections, I mentioned earlier there's like a frogs collection, Devcon collection, and so forth, is that we want to be able to synchronize those independently. So if I say, I have an app and it needs to be able to read frogs, instead of needing to synchronize like everything in my pod store, we can synchronize just the frogs, just the thing that we need for the purpose of making the current proof or for interacting with that data.
Mobile apps was the next question.
So right now there is no direct kind of mobile app equivalent of the web app functionality. Obviously, you could make a embed some web code inside a native app, but there's not like an native iOS or Android library for this right now. I'd be interested in the question is about hacking on Android in relation to iframes. I'd be really interested to talk to whoever asked that question about the specific things they've encountered with that, because we're very interested in trying to test out some of these security risks. If we can create a reproducible hack, we'd be very interested in trying to figure out how to close that loophole.
Just to interject, Rob, we're probably going to have a few extra minutes before closing ceremonies. So
okay.
Is it fair to say whoever asked that question, or if your question doesn't get answered, you can meet Rob in the back corner? Am I allowed to pitch that?
Oh yes, yeah. Don't worry.
Shell out your time.
Come and bother me after the.
All right, Rob will hang out in the back corner
I'll
if you don't get
definitely
your question asked, or if you ask that question.
Okay, so how to build and verify custom computation. So right now, so the point of something like GPC is it's general purpose circuits, which means you get these kind of like Lego bricks basically to build up your proofs. That gives you a reasonable amount of flexibility. It doesn't give you the same amount of flexibility you would have if you were writing your own code in Circom, for example. So right now, there are a few different ways that kind of flexibility could be achieved. But it's not easy to support certainly using the Z API. That's not an action that you'd be able to take right now. So you can't put totally custom circuits in there. You are limited to what you can configure using the options that GPC gives you. Having said that, GPC is very configurable and flexible, and you can compose some pretty interesting proofs using that. So I'd recommend reading the documentation on GPC and just getting really familiar with what that can do.
We'll make this the last question, this top question here, Rob, and then wrap.
It seems users can log into Zupass by email verification even when they lost their passwords. This is correct. You can do that. You can log it. So if you lose your password, you can reset your account in Zupass, and that will reset your account. You will lose access to whatever encrypted data you had previously. So your end-to-end encrypted backup will no longer be accessible to you because the password is the decryption key for that end-to-end encrypted blob. Because a lot of what we do in Zupass involves tickets, there's a kind of complicated authentication system here where if you prove ownership of an email address to Zupass by verifying your email, we give you a cryptographic credential that says this person has proven ownership of this email address, and then you go to, like in the case of Devcon, you go to Devcon's ticket server. This is kind of behind the scenes in Zupass, but it will go to the Devcon server and say like, hey, I have ownership of this email address. Do you have any tickets for me? And then they will issue you a ticket to the identity that you're presenting. If you reset your account, you'll get a new identity, so you'll get a new public key, but you will be able to prove ownership of that email address again. You become effectively the new owner. Your new account becomes the new owner of that email address. So when you go to the Devcon server and say, hey, like, can I have my tickets, please? You will get those tickets back, but they will now be assigned to a different public key. So you can't take over an existing account by resetting the email address.